formula to do when. We've learned a lot of formulas. I don't know if you've realized that. Okay, and I want you just to real quick before we start what a conditional probability is to go over some of these formulas. We learned about this addition rule. Please notice what the addition rule says. It says the probability of event A or event B happening. There's that word or. So the probability of picking a jack or picking a red card. Probability of drawing a king or, okay, you hear that or word? That formula, if you remember, says take the probability of A, add it to the probability of B, and then always put what right here? Do you remember? Subtract the probability of A and B occurring at the same time. Meaning that was when we had to do the mutually exclusive stuff, okay? But if you see that word or within a probability question, this is what you do. That's the formula you use, okay? The key word here, or. Last class with this worksheet with the tornado on it, the independent and dependent events, we did multiplication rule. Multiplication rule. And multiplication rule had the probability of A and B occurring. So me drawing a king and drawing a queen, okay, 2 picks. And that was probability of A times the probability of B. That's what we did all on that sheet. So look for that word and again, and we'll go through it when we do the study guide for the test, and I'll make sure I kind of stress out the word and, okay? The probability of this and this happening, the probability of this or this happening. This new word we're gonna look for is the word given, or it looks like a slash mark, and it refers to what's called conditional probability. Conditional probability. Gotta spell it right. So just to tell you what it says, the definition, it says the probability of event A occurring given, that's the key word there in a sentence, given event B has or already occurred. And they're going to use this word given, and it looks like this. The probability of A given the probability of B. Meaning B already happened, what's your chance of A happening? And the formula looks like this. You take the probability of A and B, and you divide it by the probability of B. And that's what's called a conditional. Now, let's just go back into our idea of Venn diagrams one more time. If this is the probability of A, and over here is the probability of B, where would the A and B occur? Would it be both of these, or would it be the football shape? Do you remember? And is the football. It's the football. So some books write it like this. That right there is what you're looking for. All right, so we're going to do just a few of these, and then your homework tonight is going to be a little bit of what you just were learning last time with the independent stuff. And then just a few of these. Look for the word given. Look for the word given. If they use that word in a sentence, what's the probability of it being a male given that it's a nurse? You know, that it was already a nurse kind of thing. Like that's the word you're looking for, given. Then you're going to use this formula. So let's do just a few examples of this. And then, I like to use cards. And then I think I'm going to use this little chart, and that's it. All right, so we're going to do a deck of cards because we love cards. Deck of cards. And you're going to find something always happening with these. I want the probability of picking a queen given that I have a face card. in my pocket. Probability of picking an ace lettered card. And I'll do one more. Probability of a heart with a number given a red card. All right, so here's your form. This is your deck of cards. You want the probability of that I'm going to go pick event A being a queen, given that event B, which is a face card, has already occurred. So again, this is kind of confusing. Just go with this formula though. The formula says for this given little statement here that you would take the probability of being queen and a face card, right? And what would you divide that by? Look at what this worksheet, what this sheet just said.
Face card.
You would divide it by the face card. Exactly. Hey, hun. Okay, so think of this phrase, queen and face card. Queen and face card. How many face card queens are there?
4.
Isn't a queen a face card no matter what? 4 out of what? So 4 out of 52 would be on the top. And I would divide that by how many, what's the probability of me picking a face card? How many face cards are there? Do you know what to do when you divide two fractions? Have you heard of it? Same change flip, have you heard of that? When you same change flip this, I just want to show you what's going to happen. The 52s are going to go bye-bye. So whatever that bottom number is, just say goodbye to it. Your final answer is 4 out of 12, which reduces to what? 1/3. Your chance of picking a queen, given that you've already picked a face card, is a 33% chance. If you've already picked a face card. That's pretty good. I mean, not bad, not great, but good. Let's do this again. Probability of getting ace card, given that you already have a lettered card in your pocket. Okay. So again, I'm going to write this out. I would say the probability of me picking an ace and a lettered card divided by what? Probability of me getting a lettered card. Okay, so again, think of the intersection of being an ace and being lettered. Aren't aces lettered? Right? Okay, how many aces are lettered? 4 of them out of 52. Okay, now let's divide that by the total amount of lettered cards. How many total lettered cards are there? So let me think, 4 aces.
16.
Would you agree 16? Because there's 12 of the queens, jacks, and kings, and then add the 4. So 16 out of 52. Ignore the 52s, they're going to divide out. And what's your fraction there? 1/4, 25% chance of, there's a 25% chance that if you had picked a card and you already knew it was a lettered card, that it was going to be an ace. Does that make sense to you? Okay, we'll do one more here. Well, you do this one, actually. I'll take a minute just to see if you can do it. Probability of picking a heart with a number on it, given that you have a red card, that you already know it's red. All right. Almost done here. Probability of a heart with a number on it. This is probably where you have to do most of your thinking because you're like, okay, how many cards are hearts with numbers on them? So that would be like 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are the numbered cards. And then there's 2 reds, right? 2 of them that are, well, hearts, excuse me, however many hearts there are. So what did you say for that one? 9 out of 52, because we're still talking about the whole deck. Yeah. Are you giving me the answer already? No, you're giving me the answer. You should be giving me the answer already. Probability of heart with a number and that it's red divided by the probability of it being a red card. That's what you should have written, correct? Okay. So how many are red heart numbered cards again? How many are red heart numbered cards? 9 of them out of a total, how many in your deck? 52. How many cards in your deck are red? Because there's the red hearts and there's red diamonds, which is 26 out of 52. Ignore these 2 numbers, by the way, they should be the same. You should be able to divide them. And you would get 9 out of 26, which I think that's it. Yeah, that reduces. Okay. We're going to just do one more with a two-way table, and I'm done. This is just a two-way table. You can write it down if you want to. You can kind of follow along. Hopefully you'll understand. This is a table of students taking statistics at a high school. The full-time students, the part-time students, the females, the males, the total, etc. Okay, so we're going to say that. Full-time, part-time, total, student taking statistics. Students taking stats. And if you want to write it down, you can. You can kind of just follow along if you're understanding what to do. So I want to find the probability that I'm going to choose a full-time student given that I've already chosen a male student. Okay. So I need to find out the probability of being full-time and being male and divide that by the probability of being male. How many full-time male students are there? Do you all agree 12 full-time and male? Right there? Out of how many? Would I choose 40 or would I choose 71 or 28? What did I choose? 71. Correct. Out of the total, 71. So 12 out of 71 are full and male at the same time. Now, in the whole entire stats class, how many are male? What would you say down here then? How many are male? 28 out of 71. So then pretend the 71s divide out. Just do 12 divided by 28, which is 3/7. Now, I've changed it on you to do male given full-time. You would think these should be the same, don't you? Well, what's my chance of picking a full-time student that I already know that I have a male student here, as opposed to what's my chance of picking a male student given that I've already had a full-time? Those aren't going to be the same, surprisingly enough. All right, see if you can do this one. Probability of being male and full-time divided by what this time? The full-time, because you already know you have a full-time student. So the top fraction would be the same, but the bottom fraction would change. Being male and being full-time is still 12 out of 71. Oops. What does the bottom one fraction become, though? 40 out of 71. Full-time students, there are 40 of them out of 71. So what should your fraction end up being? What over what? 12 out of 40, which reduces to 3/10. Last one. What's your chance of picking a full-time student given that you already have a part-time student? Let's do it. full and part-time divided by part-time. How many full part-time students are there?
Zero.
There's not, you can't do that, okay? If I've already picked a part-time student, my chance of it being a full-time on is not gonna happen. It's just 0, okay? So that's just the whole idea of this conditional probability, meaning that you've already established this part right here. You've already established the event B occurring. If I have a part-time student already in my pocket, I can't pick for a full-time student. It's just not going to happen. He's already part-time out of that. So that would be called your conditional probability. So with that said, we're done. Your homework is, if I can find my sheets. You are leaving at 10:10. No, 10. I'm sorry, I'm so confused. 10, which is a whopping 7 minutes away.
Not doing it.
I know, you're not gonna do it. I know.
I'm gonna get it.
I'll do it
Thank you,
tonight.
Oh
Keegan.
my.
Thank you, Keegan.